So we're going to officially go over how to complete radical equations, section 11.3. So the first thing I want to show you is just your inverse operations are like addition, subtraction, multiplication, division. Squaring a number and taking the square root are also inverse operations. So for something like number 1, we have a radical equal to a value of 5. So you have to make sure the radical is isolated where it is here. So to get this, solve for x, to get x out of the radical, we have to square both sides, because what you do to one side, you must do to the other. So the square root squared gets the x out of the radicand. So now it's just x equals and 25. And just check it. Is the square root of 25 5? Yes. All right, next one here. Again, the radical is isolated, so that's good. It's equal to 5. So we square both sides. When you have an expression like 2x minus 3 in your radicand, when you square that side, it's just 2x minus 3. Again, the radical and the square undo each other, but the radicand stays the same. Then you have equals to 25. You're going to add 3 to both sides, divide by 2, and you get x is 14. Again, you can check that. 28 minus 3 is 25. Square root of 25 is 5. This example here has the square root of x minus 3, and then you're adding 8 to that radical expression there, and it equals 15. So this is not isolated. We want to get this radical alone. So how do we get rid of that plus 8? Again, an inverse operation, we subtract 8. So we have root x minus 3 equals 7. Now, to undo that radical, we square both sides. So x minus 3 equals 49. Add 3 to both sides. X is equal to 52. Again, you can check that. 52 minus 3 is 49. Square root of that is 7. 7 plus 8 is 15. Let me jump down to number 4. This one has a little bit more work involved. Again, we want to get rid of this minus 1 here. So I'm going to add 1 to both sides. You always do your adding and subtracting first. Now, we have a coefficient of 4. We have to divide by 4. Okay. Undo the radical by squaring both sides. So now I have a half x plus 2 equals 9. So we're going to subtract 2. We'd get a half x equals 7. Multiply both sides by 2. We get x equals 14. Okay, if we want to check that, half of 14 is 7. 7 plus 2 is 9. Square root of 9 is 3. 3 times 4 is 12. 12 minus 1 is 11. So that's good. Number 5, same thing. Isolate that radical. We want to get that alone. So we're going to subtract 7 from both sides. So now we have the square root of x plus 4 equals negative 9. Now, at this point, hopefully you can notice that you have a square root equal to a negative. We're solving radical equations. We're just having the positive roots. So because it's a negative, there is no solution for this. There is no value for x that will make that true. Number 6, I'm just going to do the first few steps of this one. You want to make sure that you don't just jump and say, hey, it's no solution here. We have to check if it's no solution only after the radical is isolated. So when I divide both sides by negative 3, I get the square root of x minus 2 equals 5. That's positive now. So we can solve that. We'd square both sides. We'll get x minus 2, just do it out, equals 25. So x would be 27. And then again, you can check that and it works. The next two, I like these. They're really quick. We have a radical equal to a radical. So what you're going to do is you're going to square both sides. And what you get is just a regular equation like you did way back when. 3x minus 7 equals x plus 5. So you'll subtract x from both sides. You'll add 7. And then you'll divide by 2. Then you'll get x is 11. Now you want to make sure you start making sure both of those would be true. So I get 33 minus 7. And then I get the square root of 11 plus 15. So I get the square root of 26 equals the square root of 26. 26 is not a perfect square. However, those are two radicals, so that is correct.